So, good news, bad news, bad news, good news. Here's the bad news, okay? I misspoke when I said no other knowledge checks other than the final. We have 2 knowledge checks. One this Friday, which is a recent learning knowledge check, and one next Wednesday, which will be your semester final, which will be a comprehensive knowledge check. Okay? Your knowledge check this Friday is going to be over recent material. Okay? You since our last knowledge check, there should be 30 new topics that Alex, that I've expected you to learn, and so your knowledge check for this Friday is 275. If you get a 275 or higher, 275 topics or higher, then that's 100. If you're lower than that, then it's whatever your percentage is, or however many topics you have mastered divided by 275. Okay? Your knowledge check next week is a comprehensive knowledge check, in which case Alex wipes out all assumptions of your knowledge and starts you over from ground zero. Okay? Now, let me show you how Alex works. In case you probably kind of have an idea on this, but in case you didn't, let me show you with something called a directed graph. Okay? They're awesome. Directed graphs are very cool. The Alex Corporation, in conjunction with the National Science Foundation, many, many years ago, broke every math topic, every math concept or whatever into a series of topics, which are represented here by circles, as well as the relationship between those topics is directed by the edges here and the arrows. So down here we would have lower level math skills, up here higher level math skills, and the arrows show what is required in order for you to know that. For instance, in order for you to master this skill, maybe let's say it's multiplication, you need to know how to do addition and subtraction. Okay? And that's not really, in reality for multiplication, all you really need to know is just addition. But anyway, you need to know how to count your up to 100, and you need to know addition. Then you can learn multiplication. Alright? If you know multiplication, then you can do division. You can also do exponents. If you know exponents, you can do square roots and things like that. Okay? So, let's say that during the course of an Alex knowledge check, it asks you this question right here, and you get it right. Okay? Well, then Alex says, well, if you can do this, and you got it right, then logically, you must be able to do this topic right here, since that is a prerequisite for this topic. And since you obviously know how to do this one, then you know how to do this one and this one as well. Also, I could have inferred that from the fact that I knew this prerequisite, that I knew how to do this topic right here. Okay? If I know how to do, ask you a question, you get this one right, then Alex will assume that you know how to do this and how to do that. Right? In fact, if you get something like this correct, it's not going to ask you something lower than that. That would be a waste of its time and of your time. It already knows that you know everything below it. Okay? It also would be a little bit of a waste of your time for it to ask you to do this question right here all of a sudden. What it's going to do then is jump somewhere up here. Maybe not all the way to the top, but maybe right here. Okay? And let's say you do not know how to do this one. You get that question wrong. What is Alex going to assume?
That you don't know how to do the ones above it.
You don't know how to do the ones above it. Okay? It doesn't know about anything underneath here, but it will assume that you cannot do anything above it.
But so they give you one try for that type of problem. So what if you just make a mistake and get it wrong, but you know how to do it, and they don't give you a chance to do the others?
That's why Alex is a little more demanding than your standard test. But I mean, but if they said we're going to ask them, we're going to give them 2 tries on every one, then now you're looking at 60 questions.
Mm-hmm.
You know, it's going to, it's going to give you a fair shot. Try to do it, and it's not multiple choice.
Mm-hmm.
So yeah, but I mean that's the essence of mathematics. Can you get it right the first time? Double check your work. You know what I'm saying? Mm-hmm. You're absolutely correct. Now, in the course of asking, Alex might say, "Okay, you got this wrong, but I know you got this one right." So this is a great candidate question for it to ask you next. Okay, and this is, of course, this is all dynamic based on your performance. Okay, so if you do get this one right, okay, then after it figures out where you're at over here as well, it might ask you this question again, if there's still some time, it might ask you again, possibly, okay, if there's enough time, all right? But in the end, let's say we get this one right and we get this one right, but then we don't, these are all wrong, okay? So this would represent concepts that you have mastered, okay? The ones that are directly connected to those are topics that you are ready to learn. And then up here at the very top, past that ready to learn phase, these are other topics that are not yet learned. Okay? Any questions on how this works? Keep going, Janie.
Not really how it works, but so the ones that we have mastered, those need to be above 275?
Yes, what we would expect, what I'm expecting on Friday, is that after you take the knowledge check, then there'll be 275 circles.
Mm-hmm.
Yes.
So for comprehensive, it needs to be above that.
It needs to be also at 275.
Okay.
Okay? Now, let me, so let's say that, okay, so in the course of this year, you've learned some topics, you've learned some more topics. At your most recent knowledge check, right before Thanksgiving break, this guy was done, this guy, this guy, this guy, this guy, this guy. Those were all locked in. Those were things that you have mastered, okay? But then, in the last 3 weeks, or this week plus the last 2 weeks, you've recently learned all of the green, okay? So the green represents your growth here at this point. That represents your 30 topics, 10 topics from each week, okay? Your knowledge check this Friday is going to focus in on this region right here, asking you questions about stuff that you've most recently learned. All right, and Alex can assess this with a lot more detail. Okay, so that's your recent learning knowledge check. I would expect you to be at 275. It's the equivalent, in my opinion, of like a unit test, like a chapter test. We've gone for 3 weeks since Thanksgiving break. And hey, you know what? It's time for a test. And it's going to be over this recent learning. Now, some of you, maybe you were at 300 before break and now you're at 330, okay? And your level is normally on your recent knowledge check going to kind of somewhere stay probably around here, unless you just start getting all the questions wrong, and Alex is like, whoa, I'm going to go down here. And then you get those wrong, and then it's going to push you even down further, okay? You start answering all sorts of things wrong all the time. Probably not going to happen. But you normally are going to kind of hang out in that level. That's fine. When I assign a cumulative knowledge check, like I have for next week, Alex goes through and it says, I don't know anything about what she knows and what she doesn't know. It literally just goes through and erases all of this stuff, and you're starting off with a completely blank slate, and it's going to ask you something. It's probably going to ask you something around in the middle at the beginning, all right? They'll ask you a lot of middle questions. See if you know anything about logarithms, see if you know anything about trig, see if you know anything about sequences, see if you know anything about functions, okay? And then based on that, it will be able to very quickly say, yep, she probably knows all that, or she knows all this, or we don't know about that, and it's going to start giving you an idea from there.
It's like the first one we took.
Exactly. It's like
Okay.
the first one we took. That clear things up a little bit? So I am expecting you to be at 275 by Friday, or by the end of that knowledge check on Friday, and I'm expecting you next week to also be at 275. Okay? Other questions?
Are we allowed to have a page of notes on the comprehensive?
On both of them, yes. Page of notes, front and back, plus your trig chart. I'll give you that. So you 2 sheets of paper.
Okay.
Much scratch paper. So your trig chart, fine, front and back of the trig chart. If you don't put stuff, but then also another sheet of paper, front and back, whatever you want, for both this Friday and next week.
Okay.
Good stuff. How are we looking, John? As long as it doesn't look weird. Yeah, it's kind of a weird print, but that's okay. All right, and this, by the way, weighted graph. Nick and Jeremy, hopefully we'll be talking about this at some point. This is like the most top level stuff we talk about in computer programming. And weighted graphs are amazing. They're like, they can do so much stuff. I can't even express how much they can do. All right. So there's some administrative stuff. More administrative stuff. What we got looking at for this week: lecture today, workday tomorrow, lecture, then workday, then Friday. 3 homeworks. Homework 31, which I taught you on Friday. 32, which is today. 33, which is Wednesday. 275 topics plus your 10 at the end of your knowledge check. 10 topics due on Friday. Next Monday is sort of like a review day, where you can work on your review sheet or look on those topics. And then, like I said, I think 5th period is our exam next Wednesday. Your exam will be exams are an hour and a half.
You're doing
double booking.
half days?
They are not half days. Next Tuesday and Wednesday are full scheduled days, but you'll be taking half of your classes. Your odd classes on Tuesday. This is 5th period, so I think it's actually on Tuesday. Odd classes on Tuesday, even classes on Wednesday. Sorry. Yeah. Easy. So 1 through 5, 7, and 4, 6, 8. And it's they're an hour and a half each class. Maybe an hour 40 minutes on something like that. So you'll have plenty of time on that comprehensive knowledge check. All right. Other questions? Let's get going. Let's do some math. All right. Probably need your Alex trig chart out. Was anybody here not here on Friday? Raise your hand. You all see a sheet of paper? You can go and pass that to Jared if you don't mind.
Yeah, I would buy new paper when, but I do need books. Oh.
All right, class. So today, I'm not going to sugarcoat it, not going to hide it. We're dealing with something called Trig Proofs. So last Friday we talked about simplifying trig expressions, kind of going from step to step to step all the way down. And then we also talked about justifying them by giving reasons. Okay, well today we're going to do both sides of that. Okay, I have an identity here, 1 plus tangent squared, quantity times cotangent equals secant times cosecant. What we're going to do is we are going to step by step convert the left-hand side into the right-hand side and give a reason for each step. Let me walk around and show you. This is kind of what the answers are going to look like. A column there and a column there. Column there, column there. This is what. So you're going to want to write your answers vertically and kind of in a neat way. So right there, there's like column there, column there, column there, column there. This will be interesting. Might be interesting to study. Okay. All right. Over here on the right, I'm going to be giving you some of Mr. Goddard's tips and tricks to solving trig proofs. Okay. Tip number 1, start on the left-hand side. Step number 2, keep the right-hand side in mind. Keep the end in mind. So always be looking back and forth between the left-hand, like where you are right now, and where you're trying to go with the right-hand side. So on our separate sheet of paper, we're going to write 1 plus tangent squared, all in parentheses, times cotangent x. And then we're going to write equals. And we're going to try to do some stuff to make this look like secant x, cosecant x. always helpful to kind of look at the form. Over here I've got something plus something else times this, and over here I've got two things multiplied together. So now you might think, well, maybe we need to distribute first. That's an option. We'll kind of keep that in the back of our mind. But if I distribute, then I'm going to have something plus something else. I don't know if I want that quite yet. But I'm also looking at that 1 plus tangent squared. That's looking kind of familiar. Look over there on your Alex trig chart. Do you see 1 plus tangent squared anywhere?
It's secant squared.
It's secant squared, that's right. So secant squared x times cotangent x. And the reason, what's the name of that identity?
The Pythagorean.
Pythagorean identity. So I'll put the reason right over here on the right hand side. Looks like we're getting a little bit closer. Another one of Mr. Goddard's tips and tricks for trig proofs. Turn everything into sines and cosines. Turn it all into sines and cosines. So John, that's secant squared. How can I turn that into sines or cosines or whatever? That's secant squared. What if it's just secant, John?
Yeah, just secant. I was thinking doing cot first.
Cotangent first? Okay, fine. You know what? We'll do cotangent first, not a problem.
And then doing secant.
Sure, okay.
But we know secant is secant x, secant times secant x.
It is. Let's hold on. Okay, so fine. Let's deal with cotangent. How can I write cotangent in terms of sines and cosines? Cosine? Mm-hmm.
Cosine divided by sine.
Yep. Cosine over sine. And what's the name of that identity?
Quotient.
Yep. And remember, we can only do one thing at a time on these lines here. So you're off the hook now, John. Jeremy, how can I turn secant x into something with sines and or cosines? Yep. And then, oh, okay, secant x times secant x. What is secant x?
1 over cosine.
Okay. So I'm just going to replace this with 1 over cosine squared x. Because it's technically be 1 over cosine quantity squared. This is totally legitimate here. Cosine x over sine x. That, and the name of that identity, Jeremy? Reciprocal identity. Alright, if you notice I have two fractions and I'm multiplying. Anytime you have everything multiplying in the numerator, multiplying in terms of the denominator, then we have the opportunity for canceling things based on our algebra skills. I've got a cosine and a cosine squared, so that'll reduce one of those cosines. So now I have 1 over cosine x times 1 over sine x. Last Friday we discussed anytime you're just reducing things, that's algebraic manipulation. We'll write that as ALG, short for algebra. Alright, let's keep the end in mind here. Ooh, this is looking really good. I've got two things multiplied together. Hey, what was 1 over cosine?
Secant x.
It was secant x. And what's 1 over sine? It's cosecant x. Hey, what do you know? Based on the reciprocal identities. And we're done. We've gone from the left-hand side to the right-hand side, step by step by step, and given a reason for each one of those steps. All right, we're done. One of the nice things about the Alex answer editor is every time you type in one line and you give a reason, there's a button that's going to say like validate or justify or something like that. Click on it and it will check to see if what you typed in was entirely correct, and then it'll go to the next one. And then you can type it in and then click validate. That way you're not going to have to go all the way through here and you are not going to be able to know which line was wrong, like I had to when I was your age. Alright, but it's nice. It's going to check each step, and then it doesn't count any points off or anything. And then when you finally get it to the end, it'll be like, hooray, your proof is complete. You want to turn it in for a guaranteed 100? And you say yes. And then you turn it in for a guaranteed 100. Alright, any questions? Alright, I want you to start this next one as a table. Or as a table. Working as a table. And I'll give you a hint. You need a foil. Go and get started. Tips. Sometimes you need to foil. Nick, did Rosa leave or? She left?
Yeah.
We did it.
Class, another one of Mr. Goddard's tips and tricks is that you need to know how to expand A plus B quantity squared. Stephanie, A plus B quantity squared. Do you remember how to expand that?
A squared.
Keep going.
AB.
Keep going. Plus B squared. And that AB plus AB combines into a 2AB. AB plus AB is 2 times AB. Remember, something else you need to have memorized at all times. Now, let us apply this fact. Janie, this means if you have something plus something else quantity squared, it's equal to the first thing squared plus 2 times the first thing times second thing plus second thing squared. We can see that's exactly what we have going on here. So, Janie and McKaylee, all together here, help me apply that fact here.
Sine x squared plus 2 sine x times cosine x plus cosine x squared.
Or we would say cosine squared x.
Yes.
Yep. That's just expanding. We can do all of that in one step. No need to actually write out sine x plus cosine x plus sine x plus cosine x and sine squared, blah, blah, blah. Just go right there. Algebra. Great. Keeping the end in mind, I'm constantly looking where I am, where I'm going. 2 sine x cosine x really resembles this guy right here, 2 sine x cosine x. Would you all agree? So that part's locked in. I just need a way of getting that 1 out of sine squared plus cosine squared.
Pythagorean.
Yeah, Pythagorean identity. Now, I'm not going to rearrange this and write sine squared plus cosine squared plus 2 sine x cosine x, because I know that y'all are aware, if you have 3 things that are added together, it doesn't really matter which order they're added in, right? 2 plus 3 plus 10 is the same thing as 10 plus 2 plus 3. 3 plus 10 plus 2. Yeah, it's all the same thing. So, yeah, we could rearrange the sine squared plus cosine squared plus 2 cosine x, but whatever. The sine squared plus the cosine squared is 1. Based on why, Janie?
Based on the Pythagorean.
Based on the Pythagorean identity. And you know what? That's exactly what on the right hand side. I'm done. Not too bad at all. Let's look at another problem. Let's look at number. Yes, number 3. So go and copy number 3 down on your paper. Tangent x times 1 plus cotangent squared x. And we're going to 1 over cosine times sine. Alright, does anybody have any recommendations first? Say again? Okay, I'm assuming you mean distribute. That is an option. However, that is going to give me with something plus something else. And over here, I just have 1 term right here. So hold off on that thought. That is a way we can go down. But there is another way that I want us to think about as well.
Pythagorean.
The Pythagorean identity. It's good to have that trig chart out there, because you're going to notice that 1 plus cotangent squared, and that's the way we are going to travel here. That's equal to what, class?
Cosecant squared x.
Okay. Cosecant squared x. Sometimes distribution is the correct answer. In this case, I'll let y'all know it's not. Okay? What next, folks?
You would use the quotient identities with no.
Sure.
Yeah,
With tangent? Yeah, let's do that. You're taking Mr. Gotter's tips and trick number 3. Turn it all into sines and cosines. So tangent is sine over cosine. Someone else want to pick it up from there? Go ahead, Janie. I know you got
Would
it.
use the reciprocal identities with cosecant and do 1 over sine x.
Okay. So change that cosecant squared into 1 over sine squared x. She said using the reciprocal out, you're out now, Janie.
Okay.
Keeping the end in mind. Ooh, I like where we're going with all this. Somebody have a suggestion on what to do next?
Algebra.
Do some algebra? What do you want to do with the algebra?
This is cancel, so one of those signs will go away, and then it'll just be 1 over cosine times sine.
Yeah, cancel one of those signs. 1 over cosine, 1 over sine. That's using algebra. And I got you from here. 2 fractions multiplied, we multiply the numerators. 1 times 1 is 1. We multiply the denominators. That's going to be cosine x times sine x via algebra. And that happens to equal the right hand side. That's where we're going. Good job. Alright. That was number 3. Number 4 is pretty straightforward. Let's go on to number 5. Yeah. So on all these, we're starting with the left-hand side. So let's, on your extra paper over there, let's go and write the left-hand side down. Cosine x minus sine x over sine x times cosine x. So let's look at the type of thing we have on the left-hand side, the type of thing we have on the right-hand side. The type of thing we have over here is a quotient or a fraction or a ratio, whatever you want to call it, something divided by something else. Over here we have something minus something else. We have like two separate terms here. So I've got to somehow I'm going to have to turn this divide into some minuses, okay? And the subtraction of two things. The way we're going to do that is we're going to split up the fraction. And sometimes you have to do that. Not all the time, but sometimes. So split up the fraction. Sometimes. So that would be cosine x over sine x cosine x minus sine x over sine x cosine x. And you can see here, going back the other way, you know, we're used to combining fractions. Sometimes we have to split them up to make sure they have that same denominator on both sides. The advantage of that is you can see that I have, in this term, a cosine over a sine times a cosine, and those cosines would cancel each other out. Now, don't make the mistake that a lot of students do, and they just run and write sine x right there. It would be 1 over sine x, because this cosine reduces to 1, and this reduces 1 over 1, but the sine x is still the denominator. We end up with a similar thing over here, only it's 1 over cosine x. Once again, just by algebra. 1 over sine x is cosecant. 1 over cosine. Reason?
Reciprocal identity.
Reciprocal identities. Some of you may take more math classes in college. Some of you may not. You might see math at any point. But something that always frustrated me is that what we would all call algebra steps, textbooks and stuff normally just skip all of the algebra. And they go right from here to right here. And they kind of expect you to know that middle step. Kind of annoying, if you ask me. Just split it up. Do that. No big deal. They don't want to waste paper with textbooks and stuff like that. But anyway, we're going to go step by step, and we're going to give a reason, and no one is going to be able to argue with what we're doing, and everyone's going to be able to follow it. It's going to be great. Proving what you're doing every step along the way. All right. I think we can do one more. You want to do 7? Yeah, 7's probably a good one for us to finish on. All right, here we go. Tangent x minus cotangent x over tangent x plus cotangent x. You can see here we have a fraction, something minus something over something plus something, and what we're going to is this thing over here, so that's going to be kind of interesting.
Can the tangents just cross out with each other or not?
They cannot. You can only cancel things out when they're all multiplied with each other.
Okay.
In the numerator and the denominator. Good question. So we have a couple of options. I can think of at least two options. Somebody give me one option. Jeremy? We could split it up like we did last time. That's one of them. And another option? We got Janie.
To make them sine and cosine.
Turn them into sines and cosines. Okay. See if you can visualize in your mind. If we split this up, we'll end up having tangent over tangent x plus cotangent and minus cotangent over tangent x plus cotangent. In which case, we're still going to have to turn them into sines and cosines. Okay. I'll tell you right now, on this one, it's going to be easier for us to do sines and cosines to begin with. It's going to be long enough that way. So here we go. So tangent x is sine x over cosine x minus cosine x over sine x. Big fraction bar. Sine x over cosine x plus cosine x over sine x. Reason. Nope, not reciprocal. It's quotient. Identities. Next thing, when you have fractions that you're combining, you need to have a common denominator. Mr. Goddard's tips and tricks. Sometimes you have to combine fractions. And remember, you have to find a common denominator. So looking at this numerator here, what would the common denominator be? Robbie, what would the common denominator be between these two terms? Yep, sine x, cosine x. Which means I'm going to have to, you don't need to write this down, but I'll write here. I'm going to multiply this term by sine x over sine x. And I'm going to multiply this term by cosine x over cosine x. That's going to give me sine squared x over sine x cosine x minus cosine squared x over sine x cosine x. Big fraction bar. Now I'm going to do the same thing down here in the denominator. I'm going to need to find a common denominator. So I'll multiply this one by sine x over sine x, and this one by cosine over cosine. So I have sine squared x over sine x cosine x plus cosine squared x over sine x cosine x. Just using algebra techniques. So the numerator, I have sine squared x minus cosine squared x all over sine x cosine x. Big fraction bar, sine squared x plus cosine squared x divided by sine x cosine x. Suggestions now?
Can you flip it and then multiply them?
Absolutely. Turn fraction division into multiplying by the reciprocal. Fraction division, turn that into the numerator times 1 over all the time. So here we have sine squared x minus cosine squared x over sine x cosine x times the reciprocal of the denominator, sine x cosine x over sine squared x plus cosine squared x. That's an algebra technique. I'm going to put parentheses around everything so you can see very clearly. We have term times term divided by term times term. And the terms are what can cancel. So the sine x and cosine x cancel. That gives us sine squared x minus cosine squared x all over sine squared x plus cosine squared x. Almost finished. Any ideas on what to do next? And sine squared, cosine squared looks similar. What's that?
Do the FOIL.
A foil? I could, it's not a foil, but it's different to 2 squared. I could separate that into a minus b, a plus b. But look at that denominator, folks. Should be ingrained into your head. Sine squared plus cosine squared equals 1. So the whole denominator is 1. So I have sine squared x minus cosine squared x divided by 1. So just that's what it is. Pythagorean identity. I like where this is going because here I have something minus something else, and I look over there and I have 2 sine squared minus 2 sine squared x minus 1. And that's looking really similar to this. This one I've got a sine squared, and there's a sine squared. But this has a cosine squared, and there's no cosine squareds there. See what I'm saying? So what I might want to do is look and see, is there a way that I can turn that cosine squared into like a sine squared or anything like that? Look on your Alex trig chart.
Cosine squared u equals 1 minus sine squared.
Yep. 1 minus sine squared. You have that written down in pencil. The hidden version of the Pythagorean identity. And then if you want to, you can distribute that minus sign. So we have sine squared x minus 1 plus sine squared x. And sine squared x plus sine squared x, hey, we know that that's 2 sine squared x minus 1 via algebra. Now, we did a couple of steps that Alex would allow you to skip. Namely, this intermediate step of distributing the minus, you would not necessarily need that. You could go straight from here to here. Also, one of these middle algebra steps, when we wrote it as 2 separate terms, we could have jumped immediately here to that term, because that would have been fine. But we've got it. Today we looked at some proofs. We learned to start at the left-hand side, turn it into sines and cosines, simplify it. If you get stuck, start back over. All right?
It was foggy.